Mike Van Deeren with Vectors Inc. coming at you guys with another Vectors EDU video. Today we're going to be running through total station adjustments. So this would be the field collimation process for your F-Series instrument. This is vital to do, and I'll kind of run you guys through that process as we go along. Got it connected up with the cable to my computer. Going to use the emulator so I can show screenshots and some video so you can see exactly what the process looks like. And as we run through it, we're kind of going to cover why it's important and what the instrument is doing kind of in the background. Stay tuned. All right, so I got everything set up. You can see I've got Trimble Access open at the moment. The instrument right up here, I am connected to the S7 behind me. And I've also got a Trimble Traverse kit, one of the Neg 35 prisms down at the end of the parking lot here. So first thing I'm going to run you guys through is where to find the field calibration or field adjustments. So here off of T7, TSC 7, or the T10, these are all the Windows 10 devices. If you guys hit your hamburger button up here in the top left, you can go down to Instrument and then Adjust. If you're on an older TSC 3, you've got Jobs, Measure, Kogo. You have Instrument there in the bottom right-hand corner of your little grid on the main screen. When you're in Trimble Access, you'll find the same option. Instrument, then Adjust is what we're going for here. So there are 4 in here. We're actually going to be performing the first 3. That's going to be our recommendation. So the first one's going to be the compensator. So you guys will see what the instrument does behind me. So first thing it asks after I hit next, it wants to make sure that we're on a stable platform. I got it set up on a tripod here, dual locking, things are leveled. I'm on asphalt and things are pretty solid, so I'm going to go ahead and hit next. It's going to balance the instrument now. So all it's doing is plunging and reversing, it's spinning on different axes, and what it's doing is it's calibrating the electronic bubble inside of the instrument. So this comes back with the SurePoint technology. As legs settle or things start to move, we can get some compensation for that on uneven terrain or as you kind of work throughout the day. So all it's doing is spinning here behind me, and this takes about 60 seconds, and then we'll go on to the next procedure. If you guys need to know when to perform this, our recommendation is going to be first thing in the morning when you guys get to your job site and set up. This is something I also recommend doing if you guys break down for lunch, then come back, or if you guys are moving from one job site to the next, you've had some time in between. Every couple of hours, just do a quick compensator calibration, especially here in Colorado. I know New Mexico and other parts of the US experience the same thing. Temperatures tend to fluctuate a lot between the time the sun comes up and then in the afternoon we kind of get to peak heat. So keep that in mind. As I said, it's a quick thing to do. This is already done, and I'll take you guys on to the next one. All right, so the next thing we're going to run you guys through is going to be the Collimation and Trunnion axis tilt. So I'm going to go ahead and select that here, hit next. So this is going to show the current values. Let's say you guys just did a annual cleaning calibration, just got your instrument back. First time you guys go to perform this, you'll see the same thing I'm seeing here. The values are 0. Collectively over the year, these values are going to change. It's not a bad thing. It means, hey, the instrument is seeing multiple adjustments throughout the year, so these values are going to vary. But when you get it fresh back from a cleaning calibration, these values will be 0. So it's not, don't let it scare you if these numbers are a little bit all over the place. As long as you're able to do the adjustment and for it to accept, life is good. This is something you guys should be performing regularly. So I'm going to go ahead and hit next here. All right, so the first portion we're going to perform is going to be the horizontal. So as I'm looking down my parking lot, I've got a window down there, so kind of black or brown frame and a bunch of white brick. 600-700 feet. You guys want to pick something far away. This portion of the field adjustments is all about angular repeatability. It's what a total station is known for. So before I go in here, I'm just going to show this to you. I'm going to pull up the video on the S7. So I've got this window right down here. So what I'm going to do is I'm going to sight my crosshairs right in on the top right-hand corner of this window, and I'm going to take a measurement. Okay. Then I need to move. This is the most important part. You need to move the instrument the crosshairs off of your target that you've chosen, and then you need to come back to it. So what I like doing, if this is the window here, I'll pick something high and right, low and left. You can bounce around a little bit. So on average, minimum, you guys need to do 3 observations per face. You can go up to 5, you can go up to 9, however many you choose. 3 to 5 tends to be kind of the standard. So again, if this is my window, I'm going to sight in on something I can angularly repeat to after I move off of that target. So I'm going to take one measurement, I'm going to move off, I'm going to recenter back on it, and then I'm going to shoot it again. So I'm going to do 3 observations on face 1. At the bottom on the screen I'll show you, it says change face. We'll do the same thing on the second face, and then we basically do the exact same process for the vertical. You do need to pick something that's, I want to say it's over 35 degrees or below 35 degrees. I don't like going down because then your target is much closer to you. You can actually factor in much more error. So I'll run you guys through that and let you guys see what this looks like. All right, so I've got my window frame sighted in. I'm going to go ahead and take my first observation here on face 1. So as you can see, 1 observation is noted there on the screen. I'm going to go ahead and move off target, move back on, and then take another measurement. All right, re-sighted in, taking another measurement here. So there's 2 observations now in face 1. I'm going to repeat this one more time. All right, set it back in and last measurement. All right, so now that I have 3 observations in face 1, again, you could do 3, 5, like odd numbers. I can go ahead and hit change face down here at the bottom.
Changing face.
So the instrument just did a plunge in reverse, and I'm literally going to perform the exact same process. Sight in on the exact same target, take a measurement, move it off, the crosshairs off that target, move back on, hit measure, and I'm going to do this 3 more times. All right, so I've got 2 observations in, moved off, sighted back on my target, and here's the 3rd observation.
Changing face.
So at this point, the instrument plunges and reverses back to face 1.
Changing
I'll show you your difference in horizontal angle and vertical angle. And then when I hit continue, what this is telling you is, hey, we're done with the horizontal portion, basically swiveling with gravity here. We're then going to move to our vertical portion. So this is going to be the exact same process. We've got face 1 and face 2 again. Here we need to pick a vertical target. I want to say it's above or below 35 degrees. I prefer a high target over 35 degrees. So tall building corner, anywhere where you've got good contrast, you can repeat back to that same target you've chosen to use. So I'm literally going to perform the exact same process we just went through with the horizontal. We're now going to do this with the vertical aspect, and I'll get back to you when that's finished. All right, so I've now done my 3 observations on my vertical target in face 1. I've got 2 observations in face 2, and here's my final measurement.
Changing face.
Just like the horizontal, it's then going to do a plunge in reverse. It shows you your values, and when I hit continue here, this is going to show me my shift from a fresh cleaning calibration or whatever you had previously applied. And here are the new values. I'm going to go ahead and accept these here. If for some reason you think you jack something up, you can go ahead and hit repeat on the process. You can start over from scratch. This one does take a little bit of time. If you guys are seeing really odd bus in your vertical or horizontal on control points, this is the time I would recommend doing this procedure. All right, so the last one we're going to run you guys through is going to be the AutoLock collimation. So down at the end of the parking lot, we've got a Trimble Traverse kit, neg 35 prism, set up on a tripod. This is a procedure you guys would probably run before doing any type of traverse work, especially where your foresight and your backsight are exactly the same piece of glass, same brand. Make sure you guys clean that glass off before you get going. What this is doing, so as the EDM comes out, it takes the measurement off of your reflective surface, prism in this instance, and then gets returned. So where your crosshairs are seeing the tracker for the AutoLock, it can't be right in the middle, so it is slightly offset. I don't know if you guys have ever looked through your instrument before. When AutoLock is turned on, it might be locked onto your backsight, it might be locked onto an MT1000. You might notice your crosshairs might not be exactly where they need to be. So what this procedure does, this gives you your X, Y shift to center of glass. So I'm going to sight in on this target down here, and then I'll run you guys through this. And similar as the process before, you'll see old values versus new values. These are going to move slightly throughout the year because you guys need to be doing this on a regular basis. I prefer to do this once a month, even on an MT1000. Temperature, humidity, all these different environmental factors do come into play. Again, this is a simple XY shift when AutoLock is turned on that then moves you to center of glass. So I'm going to go ahead and hit next one more time. It says aim to target. It is locked on. I'm going to go ahead and hit next. It'll take its measurement. All the instrument's going to do is take an observation, do a plunge in reverse, shoot the target again. It's going to go through this a series of times. So I like setting my glass up on a tripod or bipod works. If it's not a super windy day, it's real important that that target does not move for you. And I prefer to do this at whatever furthest distance I'll be shooting throughout the day. So this is also something you guys might do if you're setting out new control on a brand new job site. Running through all three of these procedures would be recommended. So I'm going to go ahead and fire this up now. All right, so the instrument has finished its process. As you can see, old values versus new values. All it's done is a series of plunge and reverse. So this is centering back to glass, XY shift. All I'm going to do is accept these results, and it will go ahead and apply. At this point, you are done with the 3 recommended field calibrations. If you guys have questions, please feel free to reach out to our office. We'll help you guys out in any way we can. Thanks.